Hey, this is a true networking 101. No digital whiteboard, kicking it old school today, baby. Hey, you know what? When you have the option of buying servers, laptops, any type of device, you can buy a regular old plain old hard drive or these kind of new things we're calling solid state hard drives. What the heck is a solid state hard drive anyway? Well, to understand what that is, let me tell you what a regular hard drive is, and this is a review I know for most everybody. So real quickly, a regular hard drive is very mechanical. You actually have this platter that kind of looks like a record player, and it's got these little actuator arms on it that are actually accessing this data across the drive. The drive is the information is striped across, and it's actually moving back and forth as this drive spins in a certain direction. Now these are stacked up. These platters, actually you can buy these based upon how many platters they have. And all these devices, you have these arms, usually at the top and the bottom, and they read and write, and they're moving. That's that little squeaking sound that you hear. And these are moving incredibly fast, right? I mean, you're talking anywhere from 5,600 to up to 10,000 RPM on these devices, how fast this platter is spinning on here. Now, these are like IndyCar speeds, right? That's how fast we're running a racing motor. And so that's an important thing to remember, because what that means is just like a racing car, every component, every little thing in here is milled and matched to a very, very, very tight tolerance. They have to perform incredibly well. So when you have failures in these things, nearly 9 out of 10 times, they have to do some type of mechanical failure, and it's catastrophic. Normally when they fail, right? Typically, a lot of times you can fix these hard drives, throw them in the freezer, because you contract all those parts up, gives you enough time to grab your data off of it, and you can run it again. We'll cover that in another episode. But in a nutshell, these are mechanical. Now, a solid state drive, solid state in a electrical sense really means that there are really no tubes. There's nothing really moving in there except electrons, right? So when I'm talking about solid state, what I'm meaning is 1 or 0. So anytime you see the word solid state, always go back to this and think, it's how I'm handling 1s and 0s on that device, no matter what it is, whether it's a key or it is a solid state drive. Now, when you're looking at this, what is it that makes these drives solid state? And how are they really different from RAM? See, we're kind of used to that, right? We're used to when we kind of hit the old power button and stuff, all our memory kind of drops out. It's like, rip, everything in there is gone. But you can put these on the shelf and they'll last forever, right? I mean, how the heck does that happen? Well, let me show you. Well, in any type of solid state drive, there's really 2 major kinds that we're going to deal with, right? We're going to put the 1 and 0 up here so you can kind of remember that that's really what that's all about. Now, in a solid state drive, you have one called a NOR. A NOR is, and there's NORs and NANDs. I'm going to put them both up here because these are what we call, in electronics, we call these gates, logic gates. And logic gates, anytime you're turning to logic, you're referring to a 1 and a 0, on or off type of states. The N, anytime you see that, that is referring to a negative state, that is the on state of this device. Because see, we look at this and we always consider that this is on and this is off. When in fact, when you look at a negative, it's just the opposite. This is off and this is on. So if we know this, then we know how our information is being biased in that device and stuff. So a NOR gate kind of looks like this, electrical. It's kind of got this cool little delta shape happening. It's got a bubble at the end, and you got a couple inputs. And by varying my electricity here, what my input is on this, then I affect my truth table. So if I've got, 1s on here, or I got all 0s, if you say, then that's going to result in different things, right? Typically, on a NOR gate, it's going to be biased more to producing 1s. So that's kind of how these work. In a hard drive system or any type of storage device out there, a NOR gate is typically going to be wired in what we call parallel. So you're going to have these gates wired up, and they're going to look like this, electrically speaking. They're going to be wired up, and they're basically connecting up, and they're wiring to each other, and they look just like this. And that's how they wire up. A lot of wires is what you're really seeing here when it comes to a NOR gate. All these wires, all these components equals one very important factor that weighs heavily in that decision, and that's big daddy bucks, right? NOR gates, these are expensive. They typically hold a little bit less information too, but we won't kind of get in that little match. But that's just kind of a rule of thumb. Now, NAND gates are a little different. They're pretty groovy. A NAND gate looks like this. So we'll go ahead and put input on here. NAND gates are typically biased to being off. So typically as you start varying your inputs, on these devices and stuff, you're pretty much always going to get a 0 on that device, because this little bubble here is indicating that whatever your result is going to typically bias out as a 0 type of state in that device. And so we're going to build our hard drives mainly out of NAND gates. NAND gates are wired in what we call series. So if you're looking at how we're wiring these together, basically what that means is the input connects to the output, and the output connects to the input, and we kind of go on, right? It looks like this. So we're connecting these out, and then so on and so forth. Put the little bubble on them. There we go, like that. And that's how these are wired together. What is the big difference you can see between that and the crappy one that I drew before that looked like this? When they're connecting up, you can see that just real quickly, I'm using a whole lot less wiring, right? That's a whole lot less stuff that I got putting in here, so I get a whole lot more space to actually add that up. And that's a big advantage. That means that these are considerably cheaper in cost, and to be honest with you, a lot higher performance. Now, the downside, you're going to hear from these that people like to sell the NOR ones. And look, I don't care which one you buy, man. I'm just wanting you to have information. A lot of people are going to say that, NAND gates are like Christmas tree lights, right? Remember that they're wired in series. If one goes out, the whole strand goes bad. That's how you wire series type of stuff. Because this information, once you break that leg, how's the current going to get across? Well, it can't. It has to flow in that type of chain. Whereas in parallel, you break it, well, then the current can still flow because it has another path to kind of get around. A lot more wires, a lot of ways to kind of do that to get that through. Now, so let's put this in practice. Now that we know kind of the basic logic of how these are working, what does this hard drive look like? In a NAND type of system, because these are the most common, they're the cheapest, they're the fastest, they store the most information. They're wired up into what we call grid. This grid looks like this, obviously a lot neater. And you have rows and columns of these in here. Typically on one of these columns, you're going to call this a cell. Let me go ahead and change colors here so that we can see a little bit better. There we go. So in this cell, you're going to have what they call two transistors, two gates. Gate is a transistor, okay? So we're going to have two cells in here. And inside of one of these cells, we're going to put one here and one here. This is going to be called a control gate. This one's going to be called a floating gate. Now, as my current is passing through, the normal state for anything in NAND is that everything is turned on. Everything is ones. We've got ones everywhere, right? Everything is basically ones. And then as we start going through a cycle to read and write and store information, that's a 4, which is not. As we start going in here, we're starting to change these to zeros, right? That's how we're storing our data. We're actually changing that cell by applying various voltages to make this grid turn on and off. And the current will flow through the control gate and out through the floating gate. And that's how we are making this information actually in here. And controlling that and saying what goes inside of that cell. That is where this variance comes in, so you can actually store this information. When it's turned on and off, the state still remains the same because it doesn't matter. It's applied directly to that cell and it stays forever and ever and a day, amen. Here's the thing about these devices. As you start going through and storing this data in here, to actually make any type of change, you have to actually go through another read and write cycle to store and replace this. You've got to turn zeros to ones and ones to zeros to kind of clear that out. Over time, what happens is these floating gates here in the middle, they actually start to hold a little bit of that voltage in them still. And then they slowly start to trickle and they slowly start to fail. And what makes them fail is because they hold just a little bit more voltage in them, then they tend to build up some resistance. And so it makes them a lot harder for the control gate to send that information down. And so this maybe want to be a 0, but there's still a little bit more voltage in, and it looks a lot more like a 1, and it's really small, right? We're only talking about 0.7 volts. So the current, or the voltage in here to actually control that 1 to a 0 is incredibly tiny. It has to be. And so that's what we're looking at when we're doing it. So typically they'll fail because that they're holding it, you got some resistance in here. Now, what is my mean time between failures? It's pretty darn long. It's very comparable to what you're looking at with a standard hard drive. But just to let you know, they don't last forever and ever, amen, you know. They will fail. It's just kind of part of, we've had failures on our drives on TechWiseTV before too, and have lost data. It's just part of the process, because you add and write to them all the time, they're going to fail. So they're not the greatest thing in the world, but they are phenomenally fast. As you're booting operating systems, you're going to notice that your time is going to be cut, whack, it's going to be cut in half. You're going to have boot times really speed up. You're going to have your data time really shoot through the roof, because what you're doing is you're not on that platter where you're actually, and trying to hit that data. You're actually going straight to the grid, and there's my data found, send it out. It's that quick to move that crap out of there. So that works pretty good. And that's how solid state hard drives work. There's a lot more science into it, but understand it's a grid format. We're storing ones and zeros. They're NAND type of storage systems, and they work pretty darn groovy.